This video covers Trig Notes 2.2 and Pre-Calc Notes 5.2. This will be part 1 of the video. We're going to continue to work off of the formula sheet that you were given to try to identify trig identities. What's going to be very important when we're working with these is if we're trying to verify or identify that tangent times cotangent is equal to 1, I can only manipulate the left-hand side of the equation to show that it equals 1. So I already have my answer. The answer to this problem is 1. I just need to figure out how to get this to be a 1. And the way that I'm going to do that is use all of the different identities from my formula sheet to make substitutions to change this into something. So for example, I have a tangent and a cotangent. And one of the identities that I know from the formula sheet is that the tangent is equal to 1 over the cotangent. So I'm going to make that substitution here. I'm going to change this tangent into 1 over cotangent. And therefore, when I multiply these together, these will cancel out and it'll give me 1. And I already know that that's what I want to show, so I'm verifying that this left-hand side equals 1. Notice at no point in time did I take anything from over here and move it over there. I didn't divide by the cotangent. I'm not trying to move anything over to the same side as the 1. I'm trying to manipulate this side to get it to reduce down to 1. Well, that's going to be very important that what you do is you work with the left-hand side of the equation to make it look like the right-hand side. So let's apply that same concept here. I have to try to get this 2 minus the secant squared to equal 1 minus the tangent squared. So I'm going to go to my formula sheet and I'm going to look at my identities and try to figure out how can I change a secant squared into a tangent squared. So again, my goal is to get this to be a tangent squared somehow. I know that the Pythagorean identity 1 plus the tangent squared of x is equal to the secant squared of x. So what I'm going to do is I'm going to replace the secant squared x with 1 plus the tangent. So I'm going to first bring down the 2, bring down the minus, and change secant squared into this, 1 plus the tangent squared. Now I have to show that this is the same as 1 minus tangent squared. So I'm going to use distributive property. 2 minus 1 is 1, and I was able to get it to show that it's 1 minus the tangent squared of x. Again, you're already given your answer. You already know what your answers are in both of these problems, 1 or 1 minus the tangent squared. You have to figure out how to manipulate that left-hand side to show that it equals the right-hand side. Don't ever move anything over to the other side of the problem. You're always just working for what identity can I substitute into my problem, do the algebra involved, in this case distributive property and then combining like terms, and you were able to get it to be your answer. Alright, looking at this next example, I'm noticing that I have secant minus 1 over 1 minus the cosine, and I want this to all reduce down to just a secant. So my first bet is to try to change everything to secants. So I'm not going to be able to do anything in the numerator. But in the denominator, what I can do is change 1 to secant over secant. So 1 is exactly the same as secant over secant. So if I divide that out, it reduces down to 1. And I know that cosine, the reciprocal identity of cosine is 1 over the secant. So I'm going to change cosine to 1 over the secant. Now the reason that I specifically changed this one to secant over secant but not this one is because I noticed that when I want to subtract these, I need to have common denominators. So I'm not necessarily worried about having this be a secant quite yet. I may have to change it later on in the problem, but for right now I'm not going to. So what I can do now is leave my numerator the way that it is, and then I can combine these by saying, subtracting fractions, say you have to have the same denominator, and then you just subtract the numerators. Now the next problem is, how do I manipulate a fraction inside of a fraction? I can get rid of this by moving it, changing it from division to multiplying by the reciprocal. So this really goes away if I just multiply by the reciprocal. And the reason I want to do that now is because the secant minus 1 in the numerator and the secant minus 1 in the denominator will cancel out now. And now I just have secant. And that's what I want it to equal. So because I could show that both equal secant, then I was able to reduce that. Okay, taking a look at the next problem here, I'm noticing 1 plus the sine of y times 1 plus the sine of negative y. Right away that draws my attention to the even-odd identities. There's an identity that says the sine of negative u is equal to the negative sine of u, and yours may not be called even-odd identities. If it's not, look for this identity here on your formula sheet. I'm looking in the first column towards the bottom. So essentially what I can do for my problem is I can make the substitution if I have sine of negative y, then that's the same as the negative sine of y. So I'm going to make that substitution first. So it's not going to change the first binomial, but the second binomial, instead of being 1 plus sine of negative y, would be 1 minus sine of y. So I've made this substitution here. Instead of used, I used the variable that I have. Now I have to figure out how does this equal cosine squared. Well, if it's asking me to multiply these together, I'm going to do that. So if we FOIL this, we're going to end up with 1 minus the sine of y plus the sine of y, and then minus sine squared y. And what will happen is the sine of y, the negative sine of y and the positive will cancel out. And hopefully now you're starting to catch on to these Pythagorean identities. There's a Pythagorean identity out there that says 1 minus the sine squared of x is equal to the cosine squared of x. So what I can do is I can replace all of this with cosine squared of y, since that's our angle is y here, and now recognize that it equals the same. Okay, so if we take a look at the next example, we want to verify that this entire problem can be factored down into or set equal to 1. And so as I look at this problem, what I'm noticing is I have one term here, a second term here, a third term here, and a fourth term there. So anytime that I've got a 4-term polynomial, I usually want to try the grouping method for factoring. So what I'm going to do is, there's my first term, and my second term in a set of parentheses, and then put my third and fourth terms in their own set of parentheses, and pull out the greatest common factor for each. So in this set of parentheses, I notice that they have a 2 secant squared x in common. So if I divide by 2 secant squared x and 2 secant squared x, here they'll cancel out and give me a 1. Here they'll cancel out and give me a sine squared. Okay? Do the same process over here. Now what do they have in common? They both have in common a negative 1. So that's what I want to factor out. So my greatest common factor is a negative 1. I get sine squared x plus cosine squared x. Alright, so I'm still thinking about how am I going to be able to get all of this to reduce down to be 1. What I notice next is that this is, we go back up here, that's the same thing as cosine squared. It's a Pythagorean identity, so I'm going to change this into cosine squared. Bring down the rest of my problem. 2 secant squared x minus, and then over here, sine squared plus cosine squared, that's the same as 1. How do I know that? Well, we go back up here and manipulate this identity a little bit, or we could look at our sheet and it's already manipulated for us. But if I move this over, I can show then that just by moving the sign back over to this side, sine squared plus cosine squared, if I add those together, which is what I have here, is the same thing as a 1. So I can replace all of this with the 1. Okay, and now looking back over here, trying to figure out what to do with this, secant squared times cosine squared. Well, here's what I know about the secant squared. It's the same. There's an identity out there that says it's the same as 1 over the cosine. So now this becomes 2 times 1 over the cosine squared, and then times just a cosine squared. And then this is just be minus 1. Well, what will happen here is I'll have a cosine squared and a cosine squared, and they'll cancel each other out, and I'll just have 2 times 1, which is 2, minus 1. 2 minus 1 is 1, and again, what I wanted this to already equal was 1. So I'm able, through a process of using the grouping method for factoring, then changing using the Pythagorean identity twice here. So I'm using the same Pythagorean identity twice here, just different versions of that identity. And then recognizing that these two are reciprocal, so I use the reciprocal identity. Notice I never moved any of the left-hand side over to the right-hand side. I'm simply working at simplifying this by moving things over to the other side of by not moving things over to the other side, but rather making substitutions based upon the identities that I have from the formula sheet. So one last note before we finish off these notes here. One thing to kind of keep in mind is that this section is a lot easier because you know your end result. You already are told, like in this example, you have to try to get it to equal 1. In this example, you have to try to get it to equal to be cosine squared. And again, as you're working through these sections, it's going to be very important that you are using that formula sheet to find the identities that you can make substitutions with, and then plug them in and do the algebra as it fits.